Hello and welcome to this special preview edit of my Testing PHP course, which I've put together especially for YouTube. What you're about to watch is just a small section of the full Testing PHP course, which can be found at Gary Clarke Tech. And what we're going to do here is I'm going to get you set up and show you how you can start testing your code in PHP using PHPUnit. Being able to test your code is just one of those things which is non-negotiable. It's an absolute essential skill regardless of which programming language you use. In the Testing PHP course, I'll show you how to test an application completely, gaining full test coverage. So have a work through this preview. If you like what you see and you want to pursue this a little further, then I'll give you instructions on how you can get into the full course at the end of this video. Nice easy start in this first one. What we're going to do is install PHPUnit as a project dependency. So I've set up a very basic project. All I've got in here is a gitignore file and a todo.txt file, which is what you're looking at now. And what we're going to do is go over to Packagist. If you're unfamiliar with Packagist, it's a PHP package repository, and this is where we're going to search for PHPUnit, and this is where we'll find instructions on how we can install it using Composer. Now, installing Composer itself is beyond the scope of this tutorial of this course. However, I do have recordings on installing Composer and I'll attach those to this lesson. Let's go ahead and search for PHPUnit. So the website you're looking for is packagist.org, and if I type in the search box PHPUnit, should come up as the top result. As you can see here, over 300 million downloads, so fairly popular, fairly well tested, I imagine. We can click on this. It takes us to the PHPUnit page on Packagist, and then we just need to grab this here. So I'll copy that, and then I'll go over to my project, open up the terminal. I'll just bring this up here, and we're actually going to install it as a dev dependency. So I'll paste that in there, but I'm going to add a little option here, which is --dev, and that will install it as a dev dependency because you don't need this in a production environment. PHPUnit is for use in development and testing only. So let's hit enter. That should take a couple of seconds to install. Okay, and I now have PHPUnit installed in my project. If I go over to the side panel, you'll now see that we've got some new additions. We have a Composer lock file, we have a Composer JSON file, and we have a vendor folder. So in here we have a load of dependencies which were installed as part of the PHPUnit standard install, and if we go into the PHPUnit folder, here we can see all the actual PHPUnit files. Okay, so let's actually have a look at our Composer JSON, and as you can see, it's been installed as a dev dependency, and that really is it. PHPUnit is now installed. In the next one, what we'll do is we'll go and write our first tests. So let's move on. We now have PHPUnit installed as a project dependency. Let's actually just go and check that installation, and we can do this by running vendor bin /bin/PHPUnit. If I hit enter, so you'll see a load of options come up here. That's good because it shows that it's been installed. Don't worry about these right now. They're nowhere near as scary as what they look. In fact, they're really quite useful, and we'll be looking at some of these options later in the course. What we're looking at is this here. So it says PHPUnit 9.5.10 by Sebastian Bergman and contributors. That's the version which has installed. So we know that has definitely worked. We have that as a project dependency. Quick one on versions. It may well have installed a different version for you. If you're watching this video much later or a bit later than when I've recorded it, you could be on version 10, you could be on version 11. I don't think it's going to matter because PHPUnit, it's been around for a long time, it's very stable. Everything that which I do in this course is unlikely to be broken by using a later version. If in the unlikely version or in the unlikely instance that does happen, just check my version of PHPUnit in my Composer JSON file. I'll put the repository on GitHub and just revert to using the same version me. But like I say, very unlikely that anything that I do in this course will break because you're using a later version. Okay, so we've talked a lot there about the versions and the installation. Let's actually go and write our first test. So in the project root, I've called my project total-PHPUnit. Obviously you can call it whatever you like. In there I'm just going to create a directory called tests. Okay, and then in there I'm just going to create a test. I'm going to call this example test. Now the name is important. In order for this to work, in order for PHPUnit to work correctly, you must end the name with the word test. So here we go, and it's going to be a PHP class example test. Okay, and so there's one more step. In order for this to actually be a test, it needs to extend a class called test case, which comes from PHPUnit framework test case, and we'll have a look at that test case file in a second. So test case, this is the one that I'm talking about, PHPUnit framework test case. Let's actually go and look for that in the vendor folder, just so we know where everything is. So it's in PHPUnit, and if I look in PHPUnit here, source, and then framework, and then I'm looking for a file called test case. As you can see, it's quite big. This has grown over the years, but this is central to everything we do because we're extending this, and this is where a lot of the logic is held, which decides how our tests will work. So no need to look at this or get too concerned with it right now, but just know that this is the test case class that we are extending, and it's around 3,000 lines, so a lot of functionality, a lot of power available to us. Okay, back to our example test. We write individual tests like this. We use methods on our test class. The methods must be public. You can't use private or protected, it won't work like that. So we need to create a public function, and then we start with the word test. This is the most common way of doing it, or this is the way that we're going to do it initially. Later on I'll show you a way of creating test methods actually by using annotations, but for now we'll just stick with this convention, and so we're just going to say test that two strings are the same. Okay, simple as that. And then I'm just going to create two strings, so I'll call them string number 1, and we'll say Gary Clarke Tech. Okay, and then we'll say string number 2, and we'll just leave them identical. And then the way that we make this test work is we use something called an assertion. So this, and as you can see here, when I start typing the word assert, a load of different assertions come up, and these are what is used to check certain conditions which will make your test either pass or fail. So in our case, I just want to assert that these two strings are the same. And what this does, it takes two arguments, as you can see there, expected and actual. So it's testing that my expected result is the same as the actual. So I'll say test that string 1 is the same as string 2. Now that we've created our test, we just need to run it, and we can do this from the command line with php vendor bin PHPUnit, and then we just need the path to our test, which is example test. So tests example test. Later on I'll show you how you can run more than one test file at once. So here we only have one, so we're just going to concentrate on that. If I run this now, as you can see here, we see a dot. Now this is significant, I'll come to that more in a minute, but the most important thing is this here. It says OK, one test, one assertion. So that means that it has passed. Let's actually have a look at another assertion. So this is a quite common one. You can assert true and false. So first off, I shall assert true, and I will say string 1 equals string 2, and so we should see a passing test here because string 1 is identical to string 2. So let's go and run this again, exactly the same command, and again we get one test, one assertion. Okay, that's happy path. Now how about if I go and change this so the two strings are no longer equal? So this test should now fail. And when tests fail, you actually get more information, because if a test passes, you don't actually need that much information. However, when it fails, you want to know why it has failed. Okay, so let's go and run this. Okay, so a lot more information this time. And so the first thing we see is this. Instead of the dot, we now have an F, meaning that the test failed. Then it says there was one failure. So if we'd run more tests than one and we'd had a few failures, it'll tell you exactly how many failures you have. And it tells you where the failure is. So it's in example test, and it's the test method that tests that two strings are the same. Failed, asserting that false is true. So we're saying that we believe that string 1 is equal to 2. So we've said assert that this is true. In fact, string 1 is not equal to string 2. And so the answer is false. And then even better, I use this quite a lot, is it tells you the exact line on which test, because if you're running a lot of tests, sometimes you can get into hundreds, thousands of tests. So this really helps. You could have like several failures, and you can just work through them one by one, because it tells you the exact line of the exact test which is failing. So if we go and look at this, we're looking at line 11 in example test, and so that takes you straight there. And then we can see, okay, it's asserting that string 1 equals string 2. In fact, string 1 doesn't equal string 2, so very easy to debug when things start going wrong. A lot of good information there. And then at the very end it says tests 1, assertions 1, failures 1. Okay, so there we've written our first test. We've had a look at a passing test, we've had a look at a failing test, and we've had a look at how to actually debug why our test is failing. Let's move on. Okay, so far we've learned how to install PHPUnit, we've learned how to write our first test, so we've learned how to examine a passing test and how to examine a failing test. However, the test wasn't very useful because it wasn't testing anything, it was just testing our test. The whole purpose of testing is to actually test your code. So let's actually go and write some code, and we're going to test that instead. So in the same folder, in the tests folder, I'm just going to create a file for example functions, and that's exactly what we'll call it, example functions. And so here we can just write some functions that we want to test, so at least then we'll know that we are testing the functionality of our code. And so this first one, I will just call it product, and it's going to be a very simple test. The product is the result of a multiplication, and so that's what we'll do. We're going to multiply variable A by variable B, and we shall return that. And so we're going to test the value which is returned from this product function. Okay, return A multiplied by B. Then we need to go and write a test which will actually test that that functionality is working. Public function, and again we need to prefix it with the word test, and we'll just say test product function. Okay, then what do we need to do? Well, first off, we actually need to import our product function, so we shall require that file, require example functions.php, and then we need to actually call that function, so we shall say product equals, and it is product, and we'll multiply 10 by 2. So we'll keep it very simple because we're not testing our knowledge of maths, we're testing the actual functionality of our application. And then we can use an assertion called assert equals. This assert equals, and as you can see we're looking at expected as the first argument, so we're expecting 10 multiplied by 2 to return the value 20, aren't we? So that is the first argument. The second argument is the actual, and that is what we are getting back from the product function. So that will be our product variable, if I can spell it correctly, product, and that's all we need to do in order to test this. What I'm going to do though is actually show you that you can use more than one assertion in a test. So we'll also do it's fairly pointless, but it's just to prove, or just to demonstrate using more than one assertion in a test. We can actually use a assert not equals as well, and we'll just say 10. So obviously 10 multiplied by 2 does not equal 10, so we should get two assertions passing there. Assert that the product equals 20, that will pass, and assert that the product does not equal 10, and so that will pass as well. Let's go and actually run this test. So PHP vendor bin PHPUnit, and it's in tests, example test. Okay, so we have two tests in this file now, so it's going to run two tests. Let's run this. Okay, let's make a little bit more space. So we'll work from top to bottom. We've run two tests. We have an F and a dot. The F means that the first test failed. The dot means that the second test passed. And if we look at our second test, that's the one which we have just written. So this one is passing. And it tells us where the failure is, and it's the same failure which we had at the end of the last lesson. So let's actually go and change this so we don't have failing tests, and we can just change this assertion from assert true to assert false, and then we should have two passing tests. Let's go and run this again. Okay, now we have two tests, three assertions in total. So one assertion in our first test, two assertions in our second test. So there I've shown you how we can actually start testing the functionality of our application. We required our example functions file, and then we actually tested one of the functions within that file to make sure that it was behaving as expected, and we can see that it is actually multiplying our two numbers together correctly. In the next one, let's have a look at how we can actually test a class. Now that we've seen how to test a function, let's actually have a look at how we can test class functionality. So inside of the root folder, which I've called total PHPUnit, I'm going to create another directory inside of there. We'll call that source src, and then inside of there I'm going to create a class, and I'll call it cart, C-A-R-T. And so we'll initialize this with a couple of properties. So I'm going to say public float price, and we'll not actually give that a value, and then we're going to have a static public static float, and this will be tax, so the amount of tax which is applied to the purchase, to the cart price. Okay, and then we'll have a method called get net price, which will be the price multiplied by the static tax value. Public function get net price, and this will return a float. And so within the method we're just going to say price multiplied by. What we need to do now is actually go over to our test folder, and in here I'm going to create a test class which is dedicated just to testing our cart functionality, and this is typically of how you'll set up your tests. If I have a cart, then I'll also have an accompanying cart test to figure out its functionality, so it's a unit functionality. Okay, let's have a look. Cart test, and again, just like with our example test, we are extending PHPUnit framework test case. Okay, and we can actually use the simplify the fully qualified name by bringing that in like that, and then what do we need to do? We need to create a test which tests that the correct net price is calculated. So public function, our test methods must be public. Test, again, you're prefixing it with the word test. Net price is, uppercase that N there, net price is calculated correctly. Okay, I've spelled all that correct. So first things we need to do is import our cart, and so what I'll introduce here is I'll show you typically how I set up my tests. They usually have three phases, and this isn't just me, this is for all testing. There are three recognizable phases. There is the setup, where you bring in any dependencies or anything you need to set up before you actually run the execution, and then the second part is sometimes referred to as act, or sometimes referred to as when. So that is when you actually execute the thing which will set off what you need to test. And then you have a third part, which is where you actually make assertions. So that is sometimes referred to as assert, or referred to as then, as in given, when, then. What I like to do is I just call it make assertions. So this is how I set mine up, and this is what I call mine because it just makes it easier to understand. So the first part I call setup. The second part I just call this do something, because this is the do something part of the test which will actually trigger what we need to test. And then the last part is make assertions. And if you just set up your tests each time with those three parts, then it just makes it very clear on what you're doing where, and when you're actually triggering something and when you're actually checking something. The first thing I need to do is require my cart file. So that's inside of source, and it's called cart.php. Okay, so I'm in the test folder and the cart is in the source folder, but because I'm running this from the project root, means that I don't need to do any of this stuff here and go looking for it that way. I can just leave it as is, and this will actually work for us. And then I'm going to say cart equals new cart. Okay, the constructor doesn't require any arguments. What I need to do then is set a cart price, and I'll set this to 10. We'll keep the numbers simple. Like I said before, we're just demonstrating how to test rather than demonstrating anything too clever here. And then that brings us to the do something part, because this is where we are going to perform the functionality that we're actually going to test the result of. So we'll say net price equals cart get net price. So that's the function which is doing the work, and then we need to check that it has actually calculated the correct net price, the net price that we are expecting. So this assert equals, and we are multiplying 10 by 1.2. If we go back and remind ourselves here, in fact, no, we're not. I was meant to set this to 1.2, my mistake. Okay, so the tax is now set to a value of 1.2, and so 10 multiplied by 1.2 should give us 12. So the first thing we put here, if we go and have a look at the method, is the expected. So we are expecting a value of 12, and then the actual. So the actual is what has been calculated by our function, which is the net price here. So that is our test written. We have a setup where we've imported our cart, we've set a price on it. We have a do something where we actually call the function that we are testing, and then we are making assertions to make sure that that function has worked correctly. So let's go to our terminal and actually run this. PHP vendor bin PHPUnit, and it is in tests, and it is cart test. So this is how you isolate it to run a single test. Let's run this. One test, one assertion. So a good habit to get into is to actually go and change values just to make sure that things aren't passing by accident. So for example, if I just change this to 5, then 5 times 1.2, we should expect this not to be 12, and so we should expect to see a failing test. So for simple maths like this, then you know it's going to work and you're probably not going to get that failure. But when you're testing more complicated stuff where you might be mixing strings and numbers and things like that, always good to have a sanity check by just going back and testing that it should fail where it should fail. And so run it again, and that's good news. So it's failed and it should have failed. Failed asserting that 6 matches the expected 12. So I'll return this back to 10 because I don't like to end on a failing test. We'll go and run our tests again. And so there we go, one test, one assertion, all passing. As you can see, you should be getting used to this now. We have the one dot, no Fs or anything like that. So everything has worked. You now know how to test your first class. Let's move on. In this one, we're going to have a look at some handy command line options. So if you remember when we checked our installation, we ran this little command here, vendor bin PHPUnit. And then we had all these options here which appeared, and they look a bit scary at first because there's so many of them and it's not really stuff that you might be familiar with. So what I'm going to do is just show you a couple of these, get you used to using them, and then as the course progresses we'll use more of them, and we'll use them to our advantage in a lot of situations. So let's work down from the top. None of these ones. Looking for something which I'm fairly familiar with and which is good for the level that we're at the moment. So filter, this is a very good one. So if you recall when we were running our tests, if we go to our example test, it contains 2 tests, and you might just want to be honing in on one of the tests and checking that functionality. So if you have errors in your other tests, you don't want to be seeing that. You just want to be seeing the single test that you're working on. For example, if we were just working on this and we didn't want any information about this when we ran our tests, it would just get in our way. So what we can do is we can actually use that filter flag which I just showed you. So let's clear our terminal and we'll run not cart test, it's example test. So tests, example test, and then we're going to filter. So it's hyphen filter, and then we just need the name of the test, which I shall copy, and then I will paste that in there. So look how I've done this. It's hyphen filter and then a space and then the name of the individual test. What this will do, as you can see, we've just got one dot. So even though we've got two tests in the file, it has just run the second test. And as you can see there, one test, two assertions. So that one's pretty good, fairly easy to understand. Let's have a look at what others we can use. Again, I'm just going to make this a little bit bigger. And another really handy one that I use is this, colors. In fact, I just set this up in my config file to run, or to be set to true always, because it just helps you see instantly if your tests have passed and failed. So often I won't actually use it as a option. When we come on to creating a PHPUnit XML file, which is the configuration for PHPUnit, then we'll set it as the default there. But for now, we'll just run it as a option. So we'll run the last test, and this time we will say colours, and if I just leave it like that, the default is for it to run with colours displayed. So you're going to like this, much better, isn't it? You can instantly see if your tests have passed or if they have failed. Let's actually go and run, we'll remove the filter and we'll run the full file. Okay, 2 tests, 3 assertions. Let's actually make one of them fail. So what we'll do is we'll change this to 10 here, so we're asserting that the product is 10. We know that it isn't, that it is 20, so we should see a fail. Let's see what one of those looks like. Okay, big angry red failure, and that's perfect. So we know that we've run our tests and one of them has failed, and then the same again, it gives you the same failure error messages. All the messaging is exactly the same, except we just have red highlighting. So very good visual assistance there for when things are passing and failing. Let's have a look at another one. So this is one that I've just been playing about with recently. It's not something which I've used a lot in the past, however it's possibly something I might use a bit more in the future because I really like it. Let's have a look, and it's called test docs. This is it here, and it says report test execution progress in test docs format. See what that looks like in a second. Let's actually go and run our tests again. So again, colors and then hyphen TEST DOX. Okay, we have a failure. I don't like the look of that. Let's run it with a passing test first. It might be easier for us to understand, or understand what test docs does. And so, as you can see here, it provides us slightly different feedback, and it looks like more readable, more human readable feedback. So it says example because that is the test that we are running. So it's basically removed the word test from our test file, and then what it does here is it actually takes the name of the test and prints each out on one line with a little tick or an X saying whether they passed or not. So for the first one, test that 2 strings are the same. What it does there is it removes the word test, and then it just separates all the uppercase camel-cased letters or words with spaces, and again the same for the other one, test product function. One interesting byproduct of using test docs is if you look at the names that I've used for my tests, they're not actually very good when you actually come and read them in a human readable format without the word test there. That 2 strings are same, product function. So if someone else, maybe, I don't know, product owner or another tester or another developer was reading these, it probably wouldn't mean much to them. So it actually drives good behavior, it makes you think about writing better named tests. So let's actually go and do that. So that 2 strings are the same. What should we do here? 2 strings are the same. So basically I've just removed the word that there. And then test product function. How about product is calculated correctly? Okay, let's go and run these tests again and see if we think they're better names. Two strings are the same, product is calculated correctly. So I think that's much better way to name these tests, and I probably wouldn't have even thought about that if I hadn't tried using test docs. So these options can be quite useful, they can drive good behaviours. We will look at more of them as the course progresses, but obviously feel free to just hit vendor bin PHPUnit, have a look at them, read what the documentation says about them, and just experiment with them if you like. Let's move on. Okay, in this one let's have a quick look at test scope. So if you remember in the last one when we were looking at the command line options, we looked at something called the filter option. So we're going to sort of continue with that theme. Filter allowed us to isolate just a single test from a file. So we can run a single test from a file, we can run all the tests in a file, and we can also run all the tests in the tests folder. So we'll do each of those things one by one. Later on I'll show you how you can run like different test suites and how you can split things into groups, and we'll get into doing this really cool localized stuff. But for now let's just look at those three options. Filtering one test, running all the tests in one file, running all the tests in one folder. So a little reminder, the last one that we did was we just ran one test, which was test product function. Let's go and have a look at that test now. So it is, we actually changed the name of it, didn't we? So we actually need to grab the new name here. Good job I checked. Okay, so I'm going to just delete the old name, run that. So we're running example test and we're filtering for test product is calculated correctly, and we're also adding the colors option because we've decided that we're going to use that from now on. Okay, one test, two assertions. Let's actually now remove that filter. So I'll clear the terminal and we'll go and just remove the filter, which means that we should run two tests from the file. Okay, two tests, three assertions. Let's now clear the terminal, and if we want to run all the test files in the tests folder, we just need to specify tests, and as you can see that time we had three tests, four assertions. Let's add our colors. Three tests, four assertions. Okay, and that's it really. So I've had a look at filtering for a single test, run all the tests in one file, run all the tests in one folder, and like I say, we're going to build on it later on in the course. Let's move on. Now let's have a look at errors and the difference between errors and failures in our tests. So what I'm going to do is initially we'll just have a look at a failure. So here where I'm saying assert equals 20, let's just change this to 15 so that the test fails, and just to remind us what a failing test looks like so that we can compare it with an error in just a sec. So let's run this PHP vendor bin PHPUnit tests, and it's example test again, and I'm just going to filter for this one test, so using the things that we've learned, and we'll also have colors because that will really help us as well. Let's run this. Okay, so if you recall this, what we get is we get a red F. There was one failure, and then it tells us in which test you are getting the failure, and it tells us why, and also the line and the number. Okay, so far so good. Let's actually correct that so that we're not getting a failing test anymore, but what I'm going to do is I'm going to change this so that I'm only passing one argument into the product function. As you can see, PHP Storm's underlining this, so you can tell something's going to go wrong already. Let's go and have a look at, in fact, let's not, we'll do that when we come and do our debugging. So I'm going to run the same test again and look for the differences. Okay, so this time we have a red E, meaning error. So the difference being a failure means that you have not had the expected outcome when you've gone to perform your assertions in your tests. Okay, and so it has failed to, so say for example this one here, it's failed to assert that 20 should, or 15 should have been 20. However, an error means that there's an error in your code. Okay, you've not written your code correctly. In our case, it's an argument count error. We've not passed enough arguments to our product function. So don't think of it like where you can have errors and warnings in PHP and one's maybe more serious than the other. Errors and failures in your tests, they are two totally different things. One is a failing test, failing to do what you expected, failing to get the result that you expected. The other one means there's an error in your code. And so just like with failures, we can work through this and do our debugging. So again, there was one error, and then it tells us the actual test which is producing the error, and then the actual error itself. Too few arguments to function product. One passed in blah blah blah, and it actually tells you the line and exactly where the error has happened. And sometimes you can have quite a long backtrace. My product function may have called other functions, or it may have been deeply nested within classes or whatever. And so the way I prefer to do this, or the way I tend to do this, is first I'll work backwards from these steps here. So I'll start at the very bottom and I'll see that I have an error in example test line 18. Okay, so I can see that that is this, and then it says I need to go and look in example functions on line 3. So I'll look for example functions, and on line 3 I can then see, aha, I was meant to pass this 2 arguments. In my test I've actually only passed it 1 argument. And so that's how you would debug that. This was quite an easy one because there was only 2 steps to follow, but things can get a little bit more tricky. Okay, so that was errors really. At the bottom here what we have is just a red highlighting, because obviously it has failed, or it's not a passing test. So if it's not a passing test, whether it's a failure or an error, you will get red. You'll only get a green on a passing test, obviously. So you've run 1 test, 0 assertions, and you have 1 error. So hopefully that was clear. When you actually have more tests running, you'll sometimes see some dots, and then you'll see an E, and then you'll see some Fs, and a mixture of errors and failures. Like I say, one isn't more serious than the other or anything like that. They're 2 totally different things. Let's now move on. In this one we're not going to write any new tests, but we're going to set up auto-loading, which will really help us as we move forward. So I'm just going to return this back to the way it was, my test which we left at the end of the last recording, and then let's go over to cart test. Okay, and so as you can see here, we're doing it old school, aren't we? We're actually requiring this. What I'd like to do is be able to set up auto-loading so that we can just auto-load our classes into our tests and inside of other classes and in our client code, etc. So the way that we do this is we go over to composer.json, and then we add I'm going to add a couple of entries, one for auto-loading dev our test classes, and one for just auto-loading our classes, our application classes. And so I put a comma after this required dev for PHPUnit, and then it is auto-load, and then it is PSR4, which is an auto-loading standard for matching namespaces to file paths, that kind of thing. Like I said at the beginning, going into the ins and outs of Composer is beyond the scope of this class, of this course. However, I have done recordings on it, and I'll attach links to those recordings on this video. Okay, so then what we want to do is I want to create a mapping, and I want to create a namespace called app, which maps to this folder here, src, our source folder, because that's where all of our application classes are going to live, and I want them to live under a namespace called app, which is quite typical. If you look at things like Symfony, Laravel, they have this kind of mapping. So it's going to be app, then // and then colon, and that will map to source, src. Okay, great. And then what I want to do is add a dev auto-loading entry, and so I'm just going to paste one in here, which I've been doing on a little practice project, and so it should look like this, very similar to the autoload, except it's autoload dev, and we're creating a mapping between app tests. So we're going to create a namespace called app tests, and that will map to our tests folder. So hopefully That's easy enough to understand. Let's actually now go through our code and find the areas where we need to add these namespaces. So first one we need to look at is cart. So we're adding an app namespace, so app, and then as you can see the little squiggly lines and the underlining has gone. Let's actually go to cart test, and so as you can see here it's a different cart now, isn't it, because it has a namespace. So let's add our namespace for app tests, and then what we need to do is make sure we are getting the correct cart. So as you can see in square brackets there, it's saying is it the one in the app namespace. So we'll hit tab there, and then as you can see we're now using app cart. I think that's the only place we've used that, so it means that we don't need to use this anymore. We're not requiring cart anymore, we are auto loading it. Let's go over to our example test, and we'll just make sure that we're using the correct namespace here. So quite a bit of messing around, but after this we'll have a nice little setup. So app tests, and we've only really created 3 files, haven't we? We've created the cart, we've created cart test, and we've created example test. We do have this one bit here where we're requiring our functions file. However, we're going to be dealing mainly with classes and using methods on objects and things, so I'm happy to leave this. You can set up auto loading for function files, things like that, but we'll not bother. We'll just leave that as it is. Like I say, we're going to be taking a different strategy with this. And so when you actually alter your composer JSON, when you update the auto loading, you haven't finished there. You actually have one more step, and that is to actually dump auto load. I'll show you what I mean by that. Composer dump hyphen auto load, and then if you do a -o, what that will do, it will optimize the file. So if I hit enter now, as you can see, generating optimized auto-loading files, generating optimized auto-loading files containing 1095 classes. Okay, and so when you've done that, in fact, when you make any kind of wholesale changes or changes to file paths, changes to namespaces, always run your tests straight after to make sure nothing has broken. If you're updating from one version of software or frameworks or things like that to another, then first thing you do, run your tests, make sure nothing has broken, and you'll get your errors, you'll get your failures, and then you'll know where you just need to go and make your fixes. And we'll get into doing some of that stuff later in the course. So vendor bin PHPUnit. I'm just going to run the whole tests folder. Okay, 3 tests for assertions. We've sort of got used to seeing the colours, haven't we? Let's put the colours back in there. Okay, 3 tests for assertions. So in that one we didn't create any new tests, but it was a very useful exercise, I think, because we now have auto-loading set up. We're now auto-loading our classes, and we have namespaces set up. So with that we can now move on. In this recording, we're going to have a look at the setup method. The setup method is used to remove duplicate setup between tests, and what it does is it will run before each of the tests in your test case class. So let's actually create another test inside of this class, because I think that will help us to demonstrate this properly and help demonstrate the value of the setup method. So public function, and what I'm going to do is I'm just going to test that the static tax value can be changed, because if we look at our cart here, we have this static tax value. So I'll test that it can be changed, and that the get net price then gets recalculated using that new value. So test the cart tax value can be changed statically. Okay, and so like I say, the purpose of the setup method is to remove duplicate setup from in between your test cases or your test methods. So let's actually create some duplicate test setup, and then we'll see it in action by removing this later. Okay, so cart equals new cart, and then we need to do something, and that will be to update the tax value. Okay, so at the moment this is public. I think what I'm going to do is actually make it private, so going off on a slight tangent here, but I think it will be better code. Public static function set tax. So I'm just going to do this quickly. This will take a tax value amount, and then what we're going to do is say tax self-tax equals tax. Okay, and then back to our cart test, where we can say cart set tax, and this time we'll set it to 1.5. So when we multiply 1.5 by the cart price, we should get 15. Okay, so let's actually get that net price by performing that multiplication. Net price equals cart get net price, and then we shall make our assertion. And just give a bit more space here. Assert equals 15 net price. Okay, so hopefully no surprises there. Should make sense to you. Let's actually go and run this test. So PHP vendor bin PHPUnit test cart test, and we're just going to run all the tests in the file. And so we get 2 tests, 2 assertions. Let's now go and remove the duplicate setup in our tests by actually having a setup method which will be called before each of these. So a good way to do this is to actually create a cart property on the test class, on the cart test. So we'll just call it protected cart, and then we need our setup method. So protected function setup. Okay, I got a bit of auto completion there. I'm just going to remove this. We'll deal with one thing at once. So as you can see there, protected function setup, and we're not returning anything, it's just setting things up. So we can say this cart equals new cart. Okay, and with that one move, that means we can now remove our duplicate cart instantiations, and all we need to do is, instead of saying cart, we are going to need this cart, because it now becomes a property on the cart test. So I can find all of these and just change it to this cart, and hopefully I should be able to run this file again and all the tests should pass. Okay, so we get 2 tests and 2 assertions. So that's how setup works. I've kept the demonstration fairly simple just so it's easy for you to follow. However, for something like this, you might not actually do it because it's a very simple setup. There's no problem with doing this in a test class, which only has a couple of tests at the moment anyway. And it's actually a very simple object. This setup is more for things where you might be creating complicated objects which have dependencies, where you're injecting things like caches or database connections or things which write to files, and so you're having to build up quite a lot of an object there. But for something like this, like I say, you might not do it all the time, but I've kept it deliberately simple just so that you could follow along. In the next one, we're going to have a look at a sibling method, and that is called tearDown. We've had a look at setup and we've seen how that can be useful for creating the same setup in multiple tests in our test case class. Now let's have a look at tearDown. So the way I'm going to demonstrate this is I'm actually going to take this second test here, I'm going to cut it, and I'm going to paste it above the first test. Okay, so thinking about this, here I'm setting a static value, the tax. So when I actually go and run this, things might not work exactly as we want them to. As you can see, we have a failure, and it's saying failed, asserting that 15 matches the expected 12. So on line 39 of cart test, we are expecting a value of 12, however we are getting 15, and that is because we have set a static property to a value of 1.5. We haven't actually done any clear up, so when we actually come and calculate the net price here, it's actually using a static value of 1.5 for the tax. Okay, so this is a problem. One way we can solve this problem, okay, and I'm going to explain in a minute why this is probably not the best solution, but The main thing here is I'm demonstrating the teardown method and how it works. So one way that we can solve this problem is to actually create a teardown method. Okay, again I've used a bit of auto completion, and so what we're going to do here is after each test this method will run. So setup runs before each test, but teardown runs after each test. And what I'm going to do is I'm actually going to set the tax value back to 1.2 so that when it actually comes to subsequent tests, we should be dealing with the value 1.2, so when we perform this multiplication here, everything should work. So let's go and run the tests again. Okay, and so we're back to 2 tests, 2 assertions. Now that works, but it's probably not the best use of the teardown method. It's probably not advisable use of the teardown method. In fact, you'll use teardown a lot less than you will setup. If we have a look at what the documentation says regarding setup and teardown, it says setup and teardown are nicely symmetrical in theory, but not in practice. In practice, you only need to implement teardown if you have allocated external resources such as files or sockets in setup. If your setup just creates plain PHP objects, you can generally ignore teardown. And if we think about our code here, there's not actually anything that we've done in teardown which we couldn't have actually put in setup. Not only that, it's actually not a very good test, or it's not a very good way to use teardown, because we now have this dependency here, 1.2, which isn't declared anywhere else in our test. So we're actually relying on this value 1.2 to stay the same in our cart. Another developer could come along and say, okay, the tax value is now 1.45, or the value could actually come from a database, which would be more likely, and it could be a value which changes all the time. So we've actually hard-coded a dependency as well as probably not using the teardown method for its best purposes. So what we can do is we can comment that out, and we'll actually go and create this in the setup method. So we shall set it to 1.2, but it could be anything. What we have now though is knowledge that each of our tests will start off with the same value for the tax. So this one will start with 1.2, this one will start with 1.2, and we know that if we want to change the value within the test, then that's perfectly fine, and our tests will still pass. So let's actually go and run them just to confirm that. And as you can see, 2 tests, 2 assertions. But I'll briefly touch on something here. Testing static properties, testing static methods can become problematic because the values belong to the classes rather than the objects. So you can have hangover between tests, which is what we experienced here, and later in the course I'll touch on this again and we'll deal with the subject in more detail. In this one we're going to have a brief look at how you can use tests in order to refactor your code, and it's something which we will build on later in the course. So if we have a look at our cart class, we can see that our price property is public. What if I wanted it to be private? I wanted to make our code a little bit more secure. So I'm going to change it to private, and then I'm actually going to go and run the tests. And so we get errors. Now remember what we said about failures and errors. Errors are different things. We've not failed an assertion, we're actually getting the error from our code and not from our test. So we have 2 errors, and believe it or not, it's actually good when you see everything's failing rather than seeing little one part failing and another part's passing. It means that your problem is normally isolated to one place. Anyway, I'm going off track a bit there. So there were 2 errors. Cannot access private property app cart price, and if we see here, cannot access private property app cart price. So that tells us that there's only actually one thing which we need to fix, which is good news. So PHP Storm is telling us anyway that there's some kind of problem here. Let's go over to our cart test, and so we are setting a price here, and we've got the angry red squiggle, so that tells us that we need to change something. So let's actually create a setter, and that is the way that you access private properties. So public function set price. Okay, and this will take a price float value, and we're not returning anything, we're just setting a value. So this price equals price. Okay, and we're not done there, because if we run the tests, we're still getting the same error, cannot access a private property app cart price, because if we go over to our test, we've still not actually implemented the set price method. So let's do that now. Set price, and it means we can just take this 10, drop that in there, and we'll do the very same thing here. Set price 10. Okay, so logically we're doing the same thing, aren't we? We're setting the price to 10, except rather than using a public property, we're just using a public method to set a private property. So I should be able to run this test and see that it's passing. Let's do that. Okay, so back to 2 tests, 2 assertions. So what we've covered there is we've shown how we can actually change our code but then run our tests. So the tests will tell us if anything is broken and it'll give us clues on how we can fix it. Let's move on. Okay, how are you getting on so far? If you've made it this far, then I guess you're making pretty good progress. If you'd like to continue, then I'll leave a link at the end of this video and also down in the description. I'll see you in the full course.